Hello, Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Daniel Yahya Aziz. Uh, my number metric is B122410446. Today, I want to do BRC 1313 Programming Fundamental Assignment Project. Our lecturer is TS Dr. Muzalifah binti Muhammad Said. The title is Reactance Calculator. So, for today's agenda, the first one will go to introduction. Second one, problem statement. Third one, scope project. Fourth one, objective. Fifth one, flowchart. Sixth one, coding. And the seventh is conclusion. So, the team. So, in our team, we got Idham, Ameh, me, myself, Daniel, Nabil Tajuddin, and also Amirul. So for the introduction, I will pass to the next group member. That's all from me. Thank you.
Hello, my name is Nabil. So the purpose of this project is to build a simple and helpful reactance calculator using the C programming language. This calculator is designed to make it easier for users, especially students like us, to calculate values related to AC circuit, such as capacitive reactance, XC, inductive reactance, XL, capacitance C, and inductance L, without needing to do all math by hand. We choose the project because these type of calculation are common in electrical and electronic studies, but they can be tricky and time consuming to do manually. By turning them into a program, we save time and reduce the chance of making mistakes. At the same time, it gives us a great opportunity to apply what we have learned in programming, especially about using formulas, managing user input, and organizing data with structures. The main goal is to create a user-friendly, menu-based program that not only performs calculations accurately, but also keep a record of previous results so user can easily refer back to them. It is a small step but meaningful step towards connecting theory with real-world problem solving.
So for the problem statement, in the study of electrical and electronic circuit, calculating values like capacitance reactance, which is Xc, inductive reactance XL, capacitance C, and inductance L is essential for understanding how components behave in AC circuits. However, performing this calculation manually can be time consuming and prone to errors, especially when dealing with complex formula and unit conversion. Many students struggle with repetitive calculation during lab work or revision, and there is often no quick tool available that allows them to double check their answer or understand how changes in frequency, capacitance, or inductance affect circuit behavior. The third one is, therefore, there is a need for a simple, accurate, and user-friendly program that can perform this calculation instantly, keep a record of past results, and help users focus more on learning concept rather than just crunching numbers. For the next one is the project scope. So for our project scope, the first one is C program that simulates a reactant calculation system used in basic electrical learning. The second one, this system allows user to enter values such as frequency, capacitance, and inductance or reactance, depending on the type of calculation they want to perform. Uh, this program also calculate the desired result, which is Xc, XL, C, or L, using standard electrical formulas. Each result is stored in a structured format and kept in a history log for review during the same session. The program uses a menu-based system with at least 4 main options, including calculation, function, and a history viewer. The project applies basic C programming concepts including function loops, if-else statement, arrays, and structures. It focuses on providing a simple, fast, and educational tool for students to better understand AC circuit calculation. Uh, For the next one, I will pass to my friend.
Assalamualaikum. My name is Amirul Hakim bin Abdul Hamid. Okay, for my part is objective. To help users understand AC in circuit calculation, make it easier for users to calculate and learn about reactance in capacitors and inductors. Build a simple and useful calculator. Create a system that can conclude XC, XL, C and L quickly using input values. Practice C programming to solve real problems. Apply what we learned in class to build a working tool that support learning in electronics. Use clean coding and good structure to organize a good coding function, loops, conditioners, and structures for better readability. Keep track of parts calculation, store previous result in history log so user can review and learn from them. Support electronics learning, make students more confident and accurate when solving AC circuit problems.
Hi and Assalamualaikum. My name is Muhammad Amir bin Muhammad Noor. My matrix number is B122410515. I will be doing the flowchart explanation for this program. Firstly, we're going to start, which is the program begins execution here. This is the starting point of the calculator. And then the flow will go to show menu, which is a menu is displayed to the user with options to calculate. We have 6 options, which is capacitance reactance (C), inductance reactance (SL), capacitance C, inductance L, and a show history and also is it. Next, in the flow, we going through user input, which is the program waits for the user to select an option by entering a number between 1 and 6. Next, we're going to if the user choice 1, we will calculate the SC, and then we're going through the flow for the choice 1, which is first, the user going to input the frequency, and then the user also going to input the capacitance, and then the process happen, which is a calculation at C equals to 1 divided by 2 pi fc, and then the output will display the calculated at C, and then the result will save in history, and then it will return to menu. And if the user choice number 2, it will calculate the SL, and the user also going to input the frequency and the inductance, and then the process happen, the calculation, which is SL equals to 2 pi FL, and then the program will display the calculated SL. And then the result will save in history and return to the menu also. Next, for the choice 3, it will calculate the C. User also have to put input frequency and also a capacitor reactance at C, and then the process happen, the calculation C equals to 1 divided by 2 pi F at C, and then the result will convert result to microfarads, and then it will be displayed the calculated C, and also the result will save in the history and return to the menu. For the choice 4, if we calculate L, the user need to put input SL, inductive reactance, and also a frequency, and then the calculation happen, L equals to SL divided by 2 pi F, and then the result will convert to millihenries and will display the calculated L. The result also will record in the history and return to the menu. Next, for the choice 5, it will show the history of the previous calculation. And next, it will return to the menu also. For the choices, it will go to exit and just display the end. And it will return to the menu or terminate depending on the program design. And if the invalid choice, it will display an invalid choice message and return to the menu. So for the summary, each user option leads to a distinct calculation process, then loops back to the menu. All valid operations store the result for historical review. Invalid inputs are handled gracefully. That's all for the flowchart. Thank you.
Okay, for the system features, user input for calculation can enter values such as frequency, capacitance, inductance, and reactance based on the type of calculation. It's automatic calculation reactance that system automatically calculates XC, capacity reactance, XL, inductive reactance, and C is capacitance or L inductance using standard formulas. Result display with units. Each calculation shows the result with proper unit like ohm, microfarad, or millihenry for better understanding. Calculation history that program save all results in a session-based history, allowing users to review previous calculation anytime.
So next we're going to present for the coding explanation. So for the coding explanation, first we have directive, which is we use hashtag include stdio.h for the input and output function, and also hashtag include string.h for string function, and also hashtag define pi 3.15.6 is for constant value for calculations. Two, we have structure record to store calculation data, which is contain type, input values, and result and unit. Number three, we have global variable, records 100, which is it store up to 100 calculation, and record count equals to 0, which is exact number of saved record. And number four, we have function void save record. The program will save calculation data into array, which have no return value, just store data, and also it will increase counter after each save.
So for the next one is for the next coding explanation is the first one is function void show records. The function void show records is display all save calculation history and no return value, which is just print data. For the second line, for the second one, print header, which is show calculation history, which is the title. The function is loop through records for I equal to 0, I less than record count, I plus plus, which is goes through each save calculation. The third one is check calculation type using string compare. If XC prints capacitive reactance format, if XL print inductive reactance format, if C print capacitance format, if L prints inductance format. So for the fourth one is each print shows, which is the first one is input values, calculation, result, and unit, and the second one different format for each calculation type. So I will pass the next one to my friend.
Explain coding for programming. So at the main function, start with declare variables such as choice f, c, l, c, x, l, result 1, result 2, and use y1 for continuous program loop. So secondly is a display menu that consists of program title and group members, and there is a 6 menu option which is find xc, xl, c, l, history, and exit, and also get user input with scanf. So here at the switch statement for user choice, there's a case 1 for calculate XC capacitive reactance, and the formula is XC equal to 1 per 2 pi FC, gets frequency and capacitor input, calculates and display result in ohms. Also, it's save record using save record bracket. And fourth is each case follow the same pattern, which is it shows calculation formula and it's prompt for input values and perform calculation. Also display result and save to history. That's all from me. Thank you.
Assalamualaikum. My name is Muhammad Idham bin Fauzi. My metric number is B1224104228. Today I want to explain about the coding lah. So And we go to the case 2 because the case 1 already, my friend already explained. So case 2 is inductance reactant. The formula we use is XL equal to 2 pi FL. As we can see here, so we need to enter the frequency in hertz. So and then we need to enter the inductance. After that, as you can see here, this is the result 1. We store it in here, equal to 2 pi FL, and then save record, and then we save the record lah. If someone use the coding, and then we save the record in here, and then we use break. So and then we go to for the case 3. Case 3 is capacitance. So the formula is, as you can see here, C equal to 1 per 2 pi FC XC. So same as above, same as the formula above. We need to enter the frequency in hertz, and then XC in ohm. So after that, it convert the result. As you can see here, it convert the result to microfarad. And after we put the frequency and ohm, it will calculate the both in farad and microfarad also. So for the case 4 is inductance. The formula we use is L equal to XL 2 pi F, and then we need to enter the XL here in ohms, and then frequency in hertz. So in this case, we need to convert the answer we get to millihenries. So we need to use result 2 equal to result 1, 1000. So we can get in milli lah. And then after that, it will display both in Henry and millihenry units. So the case 5 is call show record to display history, and then case 6 is return to exit program. Default is show error message for invalid input, and after that program end with the closing bracket lah.
So from our project, we have tested using this circuit. We know that the frequency is 60 Hz, the voltage is 120 volt, the resistance is 250 ohm, the inductance is 650 millihenry, and the capacitance is 1.5 microfarad. So based on this circuit, we have test for the first which is the first choice, which is calculate XC. So the sample output in the calculator is 1768.38, which is same as the first choice, which is XC equal to 1 over 2 pi FC. We enter the frequency, which is 60 Hz, and enter the capacitance in farad, which is 15 microfarad, which is we got 1768.38, which is the same as the calculation. So for the next one, we got sample output for the second choice. The sample output for the second choice is for XL, which is 2 pi FL, the formula. We enter the frequency again, which is 60 Hz, and we enter the inductance, which is 65 millihenry, which is 0.65. So we got XL equal to 245.04 ohms, which is the same as in the calculator calculation, 245.04 ohms. So for the next one, the third choice is to calculate C, which is the formula is 1 over 2 pi F times with XC, and after that we enter the frequency, which is 60 Hz, and then we enter the XC that we got, which is 1768.38, and then we got the value of the capacitance, which is 0.000015 microfarad, which is the same as the calculator calculation. So for the next one, I will pass to my friend. That's all from me. Thank you.
For the sample output, fourth choice is the enter choice 1 until 6 equal to 4 is calculate the inductor XL, divide to 2 pi f and enter the ohms value to get the 245.04. That we enter frequency 60 and the inductor we get 0.649 Henry or 649.99 millihenry. For the fifth choice, the history, we enter the choice 5 and then we get the calculation history that show XC, XL, capacitance and inductor values. For the sixth choice, the exit program, when we enter the 6, we get the return 0 and press any key to continue. And for the invalid choice, let's say we put the another numbers between 1 until 6, like 8, you can get invalid choice. And please try again. That's all from me. Thank you.
Okay, and then we go to the next part is discussion. Discussion is we create a reactant calculator using basic C programming to help solve electrical engineering problems. This program can calculate 4 different types of reactant values that are important in AC circuits. Our team used simple programming skills like function, arrays, and loop to build this calculator. We made different functions for each task. One to save data, one to show history, and others for the calculations. This made our code easier to read and fix when we found mistakes. The program has simple menu that lets users choose what they want to calculate. It can find capacitive reactor, inductive reactors, and capacitance and inductance using the correct formulas. We also added history features so the user can see their old calculation. We learn how to use structures to organize data and how to convert units to make the result more useful. For example, we show capacitance in microfarad and inductance in millihenries because these are easier to work with. During testing, we fixed small errors and made the program user-friendly. The menu is clear and easy to follow. And we added error message for wrong inputs. This project helped us understand how programming can solve real engineering problems. We improve our coding skill and learn how to build a complete program that people can actually use for their electrical calculations. And then after that, we go to the conclusion. Our reactant calculator project successfully show how basic C programming can solve real engineering problems. We use simple programming skill like function, arrays, and loop to create a useful tool for electrical calculations. This project taught us how to organize code properly, handle user input, and store data for future use. We learned that teamwork and basic programming knowledge can create practical software that make complex calculations easy. The calculator proved that programming is valuable in engineering field and help us prepare for more advanced coding challenges. Overall, this project improved our programming skill and show us how to build useful tools that solve real world problems. Okay, that's all from me. Thank you so much.